Good morning, good afternoon. Reviewing for 1.6 through 1.7, so we should have this written down. First two problems on your quiz tomorrow, you will have to write in scientific notation. So again, remember, this is a really big number, and it's going to have a positive exponent. So our decimal is invisible, it's right here, and we want it between our first two numbers all the way over to here. So 6.59, all the zeros go away. It's going to be times 10. And now we need to count how many times it's moving. So 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be to the 8th power. Remember, raise your hand if you have a question. This one, we need to move our decimal so that I get rid of the zeros, but it's between the first two numbers, so it needs to be to here. So it's going to be 5.69 times 10, and then we have to count how many times we're moving that decimal. So 1, 2, 3, 4. It's going to be negative fourth. Remember, a negative exponent makes that number really, really small, and this decimal number is really, really small. These are the same thing. This is standard form. This is scientific notation. Okay, the next one, you have to explain the difference between, difference between the standard form of these two numbers. So again, you'll want to write them in standard form to compare them. So first we're going to write them. So 3, 5, 6. We want to move it 3 times to the right. So my decimal is here. So 1, 2, 3. Oh, 1, 2, 3. So decimal goes here, correct?
Yes.
So 1, 2, and then we only had to add 1 0. So we have 3,560. This one we're going to be moving. Remember, if I have a negative sign, I want to move it to the left. So 1, 2, 3. Again, double check. It started here, 1, 2, 3. It moved 3 places to the left. And then you're going to want to tell me what is the difference. Whether you say the 3,560 moved my decimal, I had moved it to the right because my exponent is positive. In 10 to the negative third, this one, we moved the decimal to the left, making my number really, really small. Smaller. Okay, something explaining the difference. Number is which number is greater, and honestly you just have to look at the what, the exponent, and which is the greater exponent. These next two problems are kind of the same in that sense, where if they are the same, then we have to go digging deeper and look at the decimal number, but because the exponent is bigger, this number will be bigger or greater. And then ordering from least to greatest, you're going to have like a table saying that this is the population of some countries, and you're going to have to order them from least to greatest. And all you have to do is, and this one's a little more difficult, where you have to look for the smallest exponent. So we have 17, 18, 17, 15, and 16. So this would be my smallest one. So I'm going to write these one by them. On the test, you're going to have to write the city or the countries from least to greatest, the country names. Right? Can we do that? Okay. So that's going to be the smallest. Then we go 17, 18, 17, or 16, which is the next smallest?
16.
16. if you notice, just because they have 5.2 here, or even 2.89, these don't matter. It's all about the exponents to start. Then the next would be these two. Oh, I didn't put a number by that. Then if they are the same, then you look at the exponent or the decimal number, and which is smaller, 3 or 8.8? 3. So the 3 is smaller than the 8, so this would be 3 in the line. This would be 4, and this would be 5. Okay, this is a hard one where to grade, and we grade that you have them in the right order. Okay. Okay, I'll have you write these two problems down. Leave some space. This is not supposed to be parentheses. That's a mistake, but I had I wrote it in pen, so I had to. The way that we learn this next ways when we're adding and subtracting is we have to remember that one, that they're both in scientific notation, even though this is pretty much, they'll both be on the test. But our next step is that both of the exponents are what? The same. So we want to make the bigger one the smaller one. So this 6, we want to become 10 to the 4th. Why? Because we want the 10 to the exponent to be the same. So we have 10 to the 4th, we want 10 to the 4th. Remember, if I make my exponent smaller, what happens to my decimal number? It gets bigger. So I need to move it. I subtracted 2 here, right? I need to move my decimal 2 places. So it was here, 1, 2, so now it's here. This one is going to remain the same. Now we have two numbers in scientific notation, both raised to the same power, and now we can add their numbers. So we're going to just add the decimal numbers. So 220 plus 7.29. If you need a calculator, 220 plus 7.29. 227.29, right? 227.29 times 10 to the what? 4th. Very good. You don't add the exponents. You only add the exponents when you are multiplying, like down here. You'll add the exponents. Okay? Am I done? No. It's over 10. So what do I do, Braden?
You have to move the decimal to the left to make the single digit 1.
Correct.
And
so
then you have to add how many times you move to the exponent, which is plus 2.
So I moved it. Again, I made my decimal number smaller, so I have to make my exponent bigger. So I moved 2 places, so I need to add that 2 back on. And that is my final answer. Okay, we're going to do the same thing here. We are going to make our exponents the same. So we want to make them both 3. I'm subtracting 2 here. If I make my exponent smaller, I have to make my number bigger. So by 2 decimal places. It was here, moving it 1, 2 to here. Again, taking a calculator, 310 minus, remember you're just subtracting the 2 decimal numbers. So 4.6 is my decimal over here. I have 305.4 times 10 to the what? 3rd power. Again, we're going to move our decimal. We want to move it from here over to here. I made my decimal number smaller, so I have to make my exponent bigger by 2. Okay. All right, the next two. Okay, so the next one is a product. I'm multiplying. Remember, everything is multiplying. It's 2.3 times 10 to the 5th times 2.5 times 10 to the 2nd. So this is where you can multiply your decimal numbers together. So 2.3 times 2.5, 5.75. That's my times 10 to the 5th times 10 to the 7th is, second, is 10 to the 7th. How did I get 7? I add the 2 exponents. Am I done?
Oh, no. Yeah. Yes, sorry about that.
It is in scientific notation. Okay, the next one, I have a division one. This is where I'm dividing. 3.6 for first number, remember. Oh, can't see, can you? Divided by 1.2. 3.033 repeating. So 3.03, and I'm going to put a repeating sign over it. Times 10. What do I do with the 8 and the 5? I subtract them or minus them, yes. 8 minus 5 is? 3. Am I done? I believe on your test, though, one of these, one or the other, will have to be moved. You will have to move the decimal to get it into scientific notation. Yes?
How do you want us to study for this? Just repeating this question?
I would, yes. Any problems like these from your homework, do the odds so that there are... you can find out your answers in the back of the book. You can redo, I believe, any problems on Freckle. Okay, so the last ones are word problems, when to add and subtract. You are not going to actually have to solve these ones. You are just going to have to tell me which operation you will have to use. So do you have to use adding, subtracting, multiplying, or dividing? So remember those key words. If we're talking about how much bigger something is than something else, it's usually going to be division. If you're finding, say, what is a really tall building? Tell me something.
Empire State Building.
Okay, so the Empire State Building, it says that it has a bunch of scientific notation in there. Okay, but it's saying from the base to the first floor, or whatever, the base of it is so long, and from the first floor to the tippy top of it is so long. What would you have to do to find the whole thing? The distance from the floor to the tippy top. So, this is the okay, that's a terrible drawing, but this is the Eiffel Tower. So I'm saying from the ground to the first floor is so many feet. It's going to give it to you in scientific notation. Don't worry about that. And then it says from here to the tippy top is this. How far is it from the ground to the tippy top? What would you do to these two scientific notation numbers? Let me give you a better example. Think about it this way. It is, and let's just use my drawing. This is 1 inch, and from here to here, it is 5 inches. How do I find out what it is from here to all the way to the top? You add them. You're going to add the 5 and the 1, right? So if it's not, try not to take those numbers. Oh, I have 10 seconds left. Okay, so We're just going to stop the video now. But